Hello everyone, welcome back to our channel. In this video, we are going to discuss about next permutation problem. So this question is very popular interview problem. So let's discuss this one. A permutation of an array of integers is an arrangement of its members into a sequence of linear order. For example, for array 1, 2, 3, the following are all the permutations. For 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. These are all the permutations of 1, 2, 3. So the next permutation of an array of integers is the next lexicographical greater permutation of its integer. In this case, we need to find out the next permutation of the array of integers. Let's say for 1, 2, 3, the next permutation is 1, 3, 2. So we need to return 1, 3, 2 only, not all the permutations. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible. Let's say if we have the array of 3 to 1, so we need to return its lowest possible order, which is 1, 2, 3. So for example, the next permutation of array 1, 2, 3 is 1, 3, 2, as we discussed earlier. Similarly, the next permutation of 2, 3, 1 array is 3, 1, 2, while the next permutation of array 3, 2, 1 is 1, 2, 3. Why? Because already 3 to 1 is its highest possible rearrangement. So we are just rearranging to its lowest possible order. Because 3 to 1 does not have a lexicographical larger rearrangement, that's why we rearranged as the lowest possible order. So given the array of integers nums, find the next permutation of nums. The replacement must be in place and use only constant extra memory. So this is the question. Let's go through the examples. So in the example, our nums is having 1, 2, 3. So the next permutation is 1, 3, 2. So in the second example, we have nums array is 3, 2, 1 and the output is 1, 2, 3. And in the third example, we have 1, 1, 5. So now it is 1, 5, 1 is the next permutation. So let's understand these examples. So in the first step, we find the decreasing element from the right. So we traverse from right to left and find the index of I such that nums of I is less than nums of I plus 1. In this case, if we traverse from the right, we got here 2. So 2 is less than 3. That's why this is the pivot element. We can write index 1 has the pivot element. And in this case, we traverse from right to left to find the index such that nums of I is less than nums of I plus 1. So here our 2 is not less than 1 and also our 3 is not less than 2. That's why there is no pivot element. And then in this example, if we traverse from right to left, so here 1 less than 5. So 1 is the pivot element. So index 1, this is. And in this case, if we traverse from right to left, we start from here. So here index nums of I is not less than nums of I plus 1. That's why we traverse to here. And again we check nums of I is less than nums of I plus 1. So this is also not true because 6 is greater than 5. That's why the pointer still moves to left. And now we'll check 3 less than 6. So 3 less than 6 condition is true. So that's why our pivot element is index 2. So this is the first step. So in the first step, we just traverse from right to left and check if our nums of I is less than nums of I plus 1. If yes, we note it down as a pivot. So that is the first step. And in the second step, we try to find the element just larger than this nums of I. So for this one, again, we traverse from the right to left. Let's say we start from this index and we will check if this index is greater than our pivot element or not. So in this case, 3 is greater. That's why we just do swap 1, 3, 2. And in this case, there is no pivot. That's why we won't check from right to left. And in this case, again, we will check from right to left and we will check our J is greater than the pivot or not. So here our J is greater than the pivot. That's why we just swap. And then in this case, we start from the index again from right to left. And here our 4 is greater than the pivot element. That's why we just do the swap. So after swapping 1, 2, 4, 6, 5, 3. So this is our second step. So now in the third step, we do reverse everything after index I. Index I is nothing but our pivot index 1. So here we have only one element. If we do reverse also, this is 1, 3, 2 only. And this step is not applicable here. And here also, after our pivot index, we have only one element. If we do reverse also, it will be same. And in this case, 0, 1, 2. So after our pivot index, we have 3 elements. So just to do reverse them. So then 3, 5, 6. Here, why do we need to do reverse? Because after swapping the pivot element with the greater element, this right part looks in the descending order. So if we reverse, then it makes the smallest possible number. So that's why we need to do reverse here. So now the final answer for 1, 2, 3 is 1, 3, 2, and 1, 1, 5 is 1, 5, 1, and 1, 2, 3, 6, 4 is 1, 2, 4, 3, 5, 6. And now in this case, there is no pivot. So if already this array is in the descending order with the greatest permutation. So that's why we just need to reverse this one to make the smallest rearrangement. So if we reverse, then 1, 2, 3 is the answer. So now let's note it down the steps to solve this question. Our first step is we need to find the pivot index from right to left. This is our first thing. From right to left, we need to find the pivot index. What is the pivot index? When nums of I is less than nums of I plus 1, then we can say it's a pivot index and we note it down this I value. This is the first step. And in the second step, for this pivot element, we again traverse from right to left and check our right value is the greater than the pivot element. So let's say if we start from right to left from J, if our J starts from the last index, let's say J equals to n minus 1. So we will check if our nums of J is greater than this nums of I. In this case, if this condition is true, we just do swap. Swap of nums of J and nums of I. And at the end, we just reverse the elements, reverse after I. Because after doing the swap, as we already see, the elements after ith index are in the descending order. So if we reverse, then we can make the next smallest permutation. That's why we need to do reverse. If there is no pivot element, then simply we need to do the reverse array. So this is the simple concept. So let's try to code for this one. So our approach is simple. First, we need to find the pivot element and swap with the next greater and then reverse the suffix. And in the final, if no pivot, reverse the whole array. So these are the steps. Let's try to code for this one. So first, we need to find the vector size, nums.size. And then we need to take I and assign from n minus 2. If we assign to n minus 1, then whenever we check for the pivot element, we need to write a condition for if nums of I is less than nums of I plus 1. In this case, we get the array bound cases. That's why we need to start our I from n minus 2 onwards. And then we need to traverse from right to left I greater than or equals to 0, I minus. So here our condition is simple. If nums of I is less than nums of I plus 1, if this condition true means we got the decrease element, first decrease element. So we got our pivot element, just break from this loop. And then we need to check if our I is less than 0. Because in one case, let's say if I less than 0 means there is no pivot element. That's why we need to reverse the whole array. So now write for our second step, swap with the next greater. So now we have the pivot element at ith index. Now we need to check for the next greater element. So for this one, again, we need to traverse from the right to left into j equals to. So here our condition is if nums of j is greater than our I, nums of I, we just need to swap nums of j, comma nums of I. Once this swapping is done, come out from this loop. So just break, reverse the suffix from our pivot index onward. So this is our logic. So after this, we can do return because below steps are not needed for this one. I hope you got the solution clearly. Let's run this code. Typo mistake. Yeah, our solution got accepted. Let's try to submit this one. Yeah, all test cases got passed. I hope you understood the problem clearly. If you have any doubt, please do let me know in the comment section. Please do like and subscribe to our videos. Thanks for watching.